0.0591 upon 1 into log of concentration of Fe plus 3 upon concentration of Fe plus 2. Done. Simple. If the same thing is used as cathode, then shall I represent in this way? Fe plus 3 aqueous, Fe plus 2 aqueous. So I am taking salt bridge here, interface with platinum. Respond, sir? Online, someone respond. Can I write like this?
Yes, sir.
Now tell me what happens. So this is nothing but representing as cathode. At cathode always reduction occurs, right? So I will write this reaction as Fe plus 3 aqueous gain electron to form Fe plus 2 aqueous. Now give Nenner's equation. E of Fe plus 3 get converted to Fe plus 2 equal to E naught of Fe plus 3 gets converted to Fe plus 2 minus 0.0591 upon, again, 1 only, log of Fe plus 2 concentration upon Fe plus 3 concentration. Acceptable? Right?
Yes, sir.
Next electrode, sir. We are done with redox electrode. Right? Now, next one. What they give? Twin hydron electrode. Check the spelling, correct or not? This type of twin hydron or quinol we have seen during manufacturing process of hydrogen peroxide. 2-ethyl anthraquinol. Just roughly I will give. Don't write it. Don't write it. Just reason. Then this is allowed to react with oxygen. What you got? 2-ethyl anthraquinone plus hydrogen peroxide. On adding hydrogen, this will convert back to. On adding hydrogen, it will convert back to this. On adding oxygen, this will convert back to this by losing H2O2. Can I write like this? Response, sir. What do we call it as? Something like auto oxidation. What? Listen, I will show that reaction again. Hydrogen and its compound chapter. We already discussed it. Class 11th. Last year in hydrogen and its compounds chapter, we have seen this. Exactly. See, what is it? Auto oxidation, industrial method of preparation of hydrogen peroxide. 2-ethyl anthraquinol. On adding oxygen, forms anthraquinone plus hydrogen peroxide. On adding hydrogen, this will convert back to this. So both are mutually interconvertible. So what I will do, I will remove this H2O2. I will keep on adding O2. I will keep on removing H2O2. Then equilibrium always moves in forward direction. So in that way, we will remove H2O2. So hydrogen peroxide obtained during this process is approximately 1%. On distillation, its concentration rises up to 30%. Further distillation under reduced pressure rises up to 85%. By crystallization process, you will get pure H2O2 in the form of prismatic crystals. This is how we will prepare hydrogen peroxide. Clear? So on benzene ring, if you have two H groups, then it is called quinol. If I take one benzene ring, if they are at ortho position, catechol. Sponsor. Just a moment. Let me close this. If I take benzene with, do both OH groups are at ortho position or not? So then what we call it as catechol. Then what about this one? Meta. Resorcinol. Then this is called as quinol. Right? Now what is this one? Quinone. Quinol, quinone. Clear? So what is the name of reaction given? Here. Quinhydrone electrode. So let me write that reaction. I'm taking quinol. Use raised to quinone plus 2H plus aqueous plus 2 electrons. With the reaction balance or not? Correct? So symbolically I represent this as QH2, this as a Q. Q is quinone with 2 hydrogens, so QH2. Right? Now, is it oxidation process or reduction process? Loss of electrons, no? Oxidation. Oxidation means I am writing anodic representation. Is it anodic representation or not? So now give me E. Can I call it as E oxidation? Is equal to A0 oxidation minus 0.0591 upon 2 log concentration of H plus square. Correct? If I consider this is both of them are in solid form. Can I write it? Right? This is anodic representation as anode. If the same quinhydrone, whether they have given the same reaction or not, check in class note. When it's in our target booklet, same, right? Now, if the same thing is represented as cathode, then tell me what I will write it as cathode. Respond. How I will represent? Reverse of it. So quinone plus 2H plus aqueous plus 2 electrons gives rise to quinol. Respond, sir. Acceptable? Now tell me what is E. E reduction equal to E0 reduction minus 0.0591 upon 2 into log of 1 upon H plus square. Right? So it can be used as cathode as well as anode. Means reference electrode. So can I say quinhydrone is a reference electrode and it is reversible. It is reversible with respect to concentration of H plus. Can I write it? See, if I increase concentration of H plus here, what happens to log value? If I increase concentration of H plus, what happens to log value? Increases. If log value increases, what happens to this value? Becomes negative. If it becomes more negative than E0 oxidation, what happens? E oxidation becomes negative. E oxidation becomes negative means oxidation is non-spontaneous. Correct? If oxidation is non-spontaneous, reduction is spontaneous. Means I have reversed the reaction. By changing, if I keep on changing concentration of H plus, I reverse the reaction. That is the meaning of it. Are you able to understand? Right? Now, in the same way, if I take calomel electrode, Can I say calomel electrode is a reversible electrode with respect to this electrode is reversible with respect to concentration of Cl minus? Can I say it? If I keep on changing Cl minus concentration, can I make it reversible or not? For example, take the second reduction process. If I keep on increasing concentration of Cl minus here, what happens? This becomes more negative, means reduction becomes non-spontaneous, so oxidation becomes spontaneous. So by keep on changing concentration of Cl minus, I can reverse the reaction or not? Instead of reduction, I am making it oxidation. That's why it is reversible with respect to Cl minus. Same way, can I say this also reversible with respect to Cl minus? See this reaction, right? Understood or not? All these are reference electrodes, or we are talking about types of electrodes, right? And now, have you solved that exercise? After that, one exercise is given. Have you solved those questions? No? So we will solve. Up to question number 10, we solved, I think. Electrochemistry, student content. Do we discuss at this point? Cell representation, working of cell, all these things are done, right? So let me solve this exercise. Solve that question number 11. The reduction potential of hydrogen half cell will be negative if we are talking about reduction potential of what electrode? Hydrogen half cell. The reduction of hydrogen half cell means, can I write like this? Correct? Reduction means cathodic path, no? So I can write like this. So what is E value? E reduction equal to, okay, E naught reduction minus 0.0591. So instead, okay, let it be 0.0591 upon 2 log concentration of or pressure of H2 upon H plus square. Response, sir? Correct or not? Say something. No. E naught of hydrogen electrode is already 0. Right? Now, if P of H2, H plus values. Check option 1. Substitute H plus value as 1 molar, pressure as 1 bar. So 1 upon 1. Then what is log 1? If log 1 is 0, what is E reduction? Negative. Okay, 0. Right? So they want 0 or negative? Negative. Now, observe second case. 1 upon 4. P of H2 is 1. H plus is 2. So 2 square means 4. So log 1 upon 4. Denominator is high, means log value negative. Log value negative means net value positive. Second case. 2 by 1 square. Then Log value is positive. That means what about this total value? Negative. Next, fourth case, 2 by 2. Sorry, 2 by 4 are a square, na? So 2 by 4. Denominator more. So log value negative. So net value positive. So they want net value negative means over, na? Answer is option 3. Correct? Come to next one. Reduction potential of any questions in it? Array, nothing there. I am substituting this value, man. What is pressure of H2? 2. So I am substituting here 2. So this value becomes minus 0.0591 upon 2 into log of pressure of H2 is given as a 2 divided by H plus a square. H plus value given as 1. So 1 square is 1. So minus 0.0591 by 2 into log 2. Log 2 is 0.3010. Now tell me whether this value is positive or negative. This total value. Negative only, na? Right? So they want reduction potential value negative. Yes, negative only. Right? In remaining cases, in one case you are getting 0, in other cases you are getting positive. Clear? Come to next one. Reduction potential of hydrogen electrode by keeping pressure of H2 as 1 bar. At pH equal to 10 is reduction potential of hydrogen electrode by keeping pressure of H2 as 1 bar. At pH equal to 10 is same hydrogen electrode. They are asking again reduction potential only. So tell me, same equation, na? So can write E reduction equal to minus 0.0591 upon 2 log P of H2 is 1. They gave, na? pH equal to 10 means what is concentration of H plus? 10 power minus 10. Correct? Huh? pH equal to 10 means H plus value is 10 power minus 10. Correct? Means basic medium. So now find it. Given basic medium. Sir. Yes, sir. మనం రేపు చూద్దాం సార్ రేపు చూద్దాం రేపు నేను అక్కడికి వస్తాను కదా what we have to do? Substitute it. So square, na? So what will be denominator? Minus 20, yeah? Say something. Then it goes to numerator. Plus 20. Log 10 power 20 is 20 to 10 times. So multiply with 10. 0.591. Correct or not? So value is negative. So can I write 0.591? Right, 0.591. They gave it as 0.592. That is the value closer to it. Response, sir. Come to next one. Any questions? Calculation. Easy calculation. Yeah. See the next. EMF of the cell. Nickel plus 2, gold plus 3 state, gold, E naught values are given. We need to find E of cell. What is the formula, sir? E of cell equal to E naught of cell minus 0.0591 upon 2 log concentration of product by reactant. Which will be product in this reaction? In this reaction, what is the product now? Nickel or gold, which will comes in product side? Hey, reduction, man. Reduction means gold Au plus 3 comes in reactant side, Au comes on product side. Reduction. Oxidation, Ni comes on reactant side, Ni plus 2 comes on product side. So what you will get? Can I write 6 in denominator? In any redox reaction, number of electrons gained and lost must be same. Correct? Say something. So, okay, for making you to understand, let me write like this. Can I write like this? Number of electrons gained and lost must be made equal means what I have to do? These electrons and these electrons should be equal. How can I make them equal? Multiply first equation with 3, multiply second equation with 2. So if I multiply this with 3, correct or not? If I multiply this with 2, correct or not? Then what is the overall reaction? What is the overall reaction? Response, sir. Online? Anyone alive? No one is alive. Online, someone respond.
Yes, sir.
Yes,
Can I
sir.
write like this? So total number of electrons will be 6 or not? So log of concentration of nickel power 3 upon gold concentration power 2. Acceptable? Right? Now, what is E naught of cell? Can I write E naught of cell as this as E naught oxidation part plus E naught reduction part, right? Which is undergoing oxidation? Nickel. Nickel is undergoing oxidation means is it nickel oxidation part or reduction part value? Observe this equation. Oxidation. Oxidation value is 0.25. So can I write like this? So 0.25 plus, which is undergoing reduction. Gold is undergoing reduction. Gold is undergoing reduction. But what they gave? So reduction means what I have to take? Plus. So plus 1.5. So totally 1.75. So this will be 1.75 minus. Sir, you are multiplying that equation with a 3, this with a 2. But why you are not changing E naught? E naught is a intensive property. EMF of a cell is intensive property, na? Right? If I multiply with something, E naught will never change. Gibbs free energy will change. Respond. So this minus 0.0591 upon 6 into log of Ni plus 2 square. What is concentration of Ni plus 2? Nickel plus 2 state. 0.1. Square means 10 power minus 2 upon gold 1. 1 cube means 1 only. Then it becomes minus 2 becomes, so 1.75 minus 0.0, sorry, it becomes plus 0.0591 divided by 3. So 2, 3 times cancelled. Correct? So what is this value? Can I write approximately 0.02? Alright, can I write this as 0.06? By 3 means approximately 0.02. 0.02 means can write the value as close to 1.77. So whichever option is closer to plus 1.77, that is the answer. Right? Any questions, sir, in this? One more question left. See this one? Which of the following is not a concentration cell? Which of the following is not a concentration cell? We have seen 2 types of concentration cell. Electrode concentration cell, electrolyte concentration cell. In electrode concentration cell, we are changing concentration of electrodic part, gas. Electrolytic concentration cell means we are changing the concentration of anodic as well as cathodic electrolyte. Now, what about option 3? And one more thing, in a electrode as well as electrolyte concentration cell, both sides we will take same cell, only I will change concentration. Correct? Observe first one. This side it is hydrogen electrode, that side also hydrogen electrode, right? H plus is the ion, P1, P2. Means what is this one? Electrode concentration cell or not? We are changing concentration of electrode. Now what about this one? This is also electrode concentration cell. What about this one? We are changing concentration of electrolyte. So this is electrolyte concentration cell, right? Now what about this? Galvanic cell. Two different electrodes. So it is not concentration cell. Acceptable? Online people, you are not
Yes, sir.
responding. Others?
Yes, sir.
What, sir? What? Yes, sir. Huh? By the time you respond, everything will be done. I think total class 11th and 12th portions also will be over. Right. So we are done with the types of electrodes also. Types of concentration cells also already we have seen. Right? Now one more thing left. What is it? One more thing left. What is it? Batteries and corrosion. So first let me start with batteries topic. So we will classify batteries into two types: primary cells and secondary cells. Secondary cells are rechargeable. Primary cells are non-rechargeable, use and throw, right? So non-rechargeable. Right? Example of primary. We can call it as a dry cell, or we also call it as a Leclanche cell, right? Secondary cell, example, I'm taking it as a lead acid battery. First, let me start with explanation about a dry cell. And after that, I will go with the lead acid battery. After that, we will discuss remaining different varieties of cells, right? So these two are the important things according to our syllabus, right? So first I am going with dry cell, or we also call it as Leclanche cell. When you observe this dry cell, just let me copy that image directly from Google Images. Dry cell, I am taking one image. Huh? Can I take this image? All these are okay. All these images are good only. I'm taking this image. Okay, well, understandable or not? This is battery. If have you ever opened it, cut and open it, right? Then you will find some gel type material inside. At the center, you will find graphite rod, and this is made up of zinc. Sometimes they will take zinc container, a zinc container, very thin zinc container. Inside, they will take some gel type material of manganese oxide, and at the center, you will be having graphite rod, which acts as cathode, and there will be one plastic material which will be surrounding that, so that there will be no connection between cathode and anode, right? And to have that strength, they will wrap it with some plastic material, some cover, polythene cover or something like that, right? So this is how this dry cell looks like. 1.5 volt batteries look like. Okay, what? So what happened here means zinc acts as anode. So I am taking anodic compartment. Zinc acts as anode. They have taken zinc can that is acting as anode. And graphite rod acts as cathode. Right? So that's why we can write zinc anode. So anode undergoes oxidation. So zinc gives rise to form Zn plus 2 electrons. Graphite acts as cathode. So I am writing graphite cathode. Now see this carefully. This is what behaving as, can I call it as electrolyte, but not liquid. It is a paste. MnO2 mixed with ammonium hydroxide paste or ammonium chloride plus moisture, water plus MnO2 paste, right? That acts as some gel type material, right? So there MnO2 reacts with NH4 plus 2 electrons to form MnOOH plus 2 moles of ammonia. Check whether the reaction got balanced or not. Check it. Charge got balanced. 2 positives, 2 electrons. Charge got balanced. 2 manganese, oxygens, 4, hydrogens, 8, here 6 and here 2, 8. Everything got balanced or not? Now observe the overall reaction. What is the overall reaction? What is the overall reaction? Zinc plus MnO2 plus 2 NH4 plus gives rise to 2 MnOOH plus Zn plus 2 plus ammonia. Actually, ammonia should be gas, na? But why I'm not writing it as a gas? Reason, these two readily forms this complex. This is the complex obtained. Means obtained ammonia was trapped by Zn plus 2. This MnOOH, this will convert to Mn2O3 plus H2O. Check whether it was balanced or not. 2 hydrogens, oxygens, 4, here 3, here 1, 4, 2 manganese, 2 manganese. Clear? Respond, sir. Any questions, sir, in it?
No,
now,
sir.
Here, voltage obtained, E naught of this cell is approximate, or E of this cell is approximately 1.5 volts. Actually, I will write as 1.25 to 1.5 volts. Clear? Any questions, sir, in it? Respond. Do you have any questions in it?
No, sir.
Other points you need to remember here. This MnO2, whichever we are taking here, we can call it as, it can act as depolarizer, right? It can be called as depolarizer. Reason, it is absorbing electrons. MnO2 is absorbing electrons or not, right? So reason for this is, it is absorbing electrons. If something accept electrons, what we call it as? If something accepting electrons itself is undergoing, Reduction. It can be called as oxidizing agent. So can I call it as oxidizer? Can I call this as oxidizer also? Because it is absorbing electrons, right? Response, sir. And it is absorbing hydrogens also. It is pulling hydrogens from ammonium, NH4 plus, and it is trapping that. So MnO2 can also be called as, it will stop H2 gas bubbles from accumulating by absorbing them. Any questions, sir?
No,
Now,
sir.
only problem in this cell is as the time passes by, when you start using, even if you don't use it, if I leave it undisturbed, voltage output of this battery slowly decreases. Is it clear? Right? So because of some internal resistance, voltage drops occurs continuously. If I don't use this battery for some time, if I leave it undisturbed also, after some time, what is the voltage output becomes? 0. If I use it also, slowly output voltage decreases, right? If its output voltage decreases, can I use them in watches or wall clocks? Why I cannot? I don't want to use them in wall clocks. Because its voltage output is decreasing means after a certain point, what happens? It cannot show exact time. It slows down. So it has some limitation in its use, right? Respond. So due
Yes.
to some internal resistance, due to some internal resistance, voltage output decreases. So that's why there will be always a drop in voltage or drop in cell potential. Can I say it as drop in cell potential or maybe it's drop in cell voltage, right? Even if cell was not in use. Even when cell is not in use. Clear, sir?
Yes, sir.
And I will write and become dead after some time. So to overcome this issue, right, they brought small modifications and different types of cells has been generated. Best example in that is button cells. In watches we use flat button cells, right? So that we will discuss later. So first let me complete with lead acid battery. After completing that, we will go for different types of cells. Lead acid cells, rechargeable batteries, lithium ion batteries, Edison cells, all different types of cells we use, right? So first let me come with the second type of cell, that is lead acid battery, which is rechargeable. This is rechargeable battery. These two are important according to our syllabus. Remaining things just we will learn and we will leave them, right? So let me take the image of lead acid battery. Can I take this image? Say something, sir. At home we may this one we will see at home. Yes, sir, UPS, ma'am. Correct? This is also same. This is also same. But they have shown only two outside. Remaining these things are there, no? They are closed, they are sealed. It was just a seal, nothing there. Right? Maintenance free. So it is not actual lead acid battery. I will take better this image only. Huh? Say something, sir. In this, lead act as anode. Lead act as anode. At anode, what happens? At anode, what happens, sir? Lead oxide act as cathode. What happens at cathode? Reduction. So observe these reactions. Anodic reaction. Lead with SO4 2 minus gives rise to form PbSO4 plus 2 electrons. Is it oxidation or not? Right? No. PbO2 again combined with SO4 2 minus plus 4H plus 2 electrons to form PbSO4 plus 2H2O. Check whether it was balanced or not. See the second reaction, sir, whether it got balanced or not. Check it out. Done? I'll check oxygens and hydrogen span. Right? Now, what is the overall reaction? Observe the overall reaction here. Observe the overall reaction. Lead plus lead oxide instead of writing 2SO4 2 minus and 4H plus, can I write 2H2SO4? Two electrons gained and lost. I am removing it to form PbSO4 plus 2H2O. Of course, this is less soluble in water. Lead sulfate is less soluble in water, no? So better can I write as solid? Better I will write as aqueous only because sparingly soluble. Sparingly soluble. Right? And voltage output here is approximately equal to 2 volts. How many such 2 volts are getting connected in series? 6. So what is the overall voltage output? 12 volts. So this is 12 volts at DC is sufficient to run all electronic equipment, not ACs and so on, bulbs, fan, TVs, etc. Right? Where the voltage requirement is less. Clear? Response, sir. Now you may be able to understand why lead acid batteries after certain time will add distilled water or pure water. Reason? Due to climatic changes, this may be escaped from the battery in the form of moisture. If it get escaped, what happened to backward reaction? Doesn't occur. Right? During discharging, it is putting towards out. Output voltage is towards. If E external is greater than this, battery should recharge. No? Cell reaction should get reversed. Already we have seen now. If E external is greater than E naught of cell, cell reaction should reverse. So if E external becomes greater than E of cell, cell reaction should reverse. To reverse it, H2 is necessary. Right? If H2 is not there, sufficient amount of H2 is not there, battery will not get charged properly. That's why timely we will replace that with, fill it with water. Is it clear? Deionized water. Response, sir. Now, during discharge, what happens to concentration of H2SO4? Old JEE mains question. During discharge of this battery, what happens to concentration of H2SO4? Increases or decreases? So, during discharge, concentration of H2SO4 decreases. So, can I write density of H2SO4 decreases? Response, sir? During charging,
Yes, sir.
what happens? During charging, cell reaction becomes reverse. Then what happens to density of H2SO4?
Increases.
Means as long as this keep on working, concentration of H2SO4 keep on changing, right? So it changes between density of H2SO4 changes between 1.3 gram per ml to 1.2 gram per ml. This is the density of H2SO4. Approximately 38% by mass is the percentage by mass of H2SO4. Response, sir. Any questions do you have in this?
No, sir.
So these are the two important cells. Now we are going to discuss about the third cell, button cell. We also call this as mercury cell. Button cell, or we also call it as mercury cell. What is the major role of this button cell? Why we have gone for this button cell? To provide steady voltage. A normal dry cell voltage keep on decreasing, na? So in button cell, voltage output remain same. Right? So let me take one image for button cell. Can I take this image? This image seems to be better, no? Right, I am taking this image. This only seems to. Is there anything better than this? Okay, boss, sir. Right? So what happens here? Same zinc anode. Observe. In Lackland cell also, zinc anode. Their graphite cathode, but here it is totally made up of steel. Correct? So inner steel case, outer steel case. So this total steel case will behave as cathode. Response, sir. So now In this total process, zinc act as anode. Instead of writing zinc, I will say zinc amalgam act as anode. Reason, we are taking mercury oxide. Earlier case, I have taken MnO2. Instead of MnO2, we are taking HgO mixed with graphite acting as cathode. Right? Which was completely sealed inside steel container. Right? So I am taking zinc amalgam, which is acting as anode. Zinc amalgam anode. Yes, sir. Mhm. Okay, 5 నిమిషం. Complete, huh? Awesome. Now see this, sir. I am taking zinc amalgam with base. From where I got that base? Observe this. KOH saturated with zinc oxide is absorbent material. It is behaving as electrolyte. Means base is present or not? KOH. So OH minus ions are there. So zinc is reacting with that OH minus ions to form zinc oxide plus H2O plus 2 electrons plus mercury. Now at cathode, sir, which is acting as cathode? Cathode. HgO plus graphite. This mixture is acting as cathode. What happens at cathode? Reduction. Observe that reduction reaction. HgO, we are taking mercury oxide, HgO, combined with H2O plus 2 electrons to form mercury and 2 OH minus. Now observe overall reaction, sir. Observe the overall reaction. Zinc amalgam with mercury oxide. Can I cancel these 2 electrons and 2 electrons? 2 OH minus, 2 OH minus. So what is left? On reactant side, nothing is there, right? Gives rise to H2O, H2 also gone. So gives rise to zinc oxide plus mercury. Respond, sir. So here voltage output will be constant. So output voltage will is approximately 1.35 volts. Constant voltage output. Mercury cell. Next, sir. Want to check your target booklets? Different types of cells they have mentioned. Nickel cadmium cell. Okay. Next cell, sir. Fourth type. Nickel cadmium cell. Rechargeable batteries, sir. Nickel cadmium batteries are rechargeable batteries. It will have different layers. Let me take the image. Nickel cadmium batteries. Same image only, no? Right. I am taking this image. Observe, sir. Till now, in both dry cell, button cell, right, which is acting as anode, zinc. Whereas in dry cell, which is cathode, MnO2. Whereas in button cell, HGO plus carbon. Now observe here, which is acting as anode, right? Which is acting as anode. Nickel plated steel container. Where is? Oh, they have not mentioned. Huh? Okay. Cadmium act as anode. So I am writing cadmium anode. Respective reaction. Same as above. There I wrote zinc plus 2OH minus. Here we will write cadmium plus 2OH minus. Gives rise to cadmium hydroxide plus 2 electrons. This cadmium hydroxide will break down to form cadmium oxide plus H2O. Right? Same way there, instead of ZnOH twice, I wrote ZnO plus H2O. Response, sir. Any questions in it? Nickel oxide. There, HGO. Here, NiO. So, nickel oxide act as cathode. So, I am writing 2 NiOOH plus 2 H2O plus 2 electrons gives rise to NiOH twice plus 2 OH minus. Check whether the reaction got balanced or not. Balanced? Now, what is the overall reaction? Overall reaction. Cadmium 2 NiOOH plus 2 H2O gives rise to 2 OH minus 2 OH minus 2 electrons gone. Cadmium hydroxide CdOH twice plus 2 NiOH twice. And what is voltage output? Approximately 1.2 volts. This is the nickel cadmium cell battery, right? Now, how this look like? Observe this. If you see this image, it will be separated by layers by layers. Observe, porous separator. One layer is cadmium hydroxide layer. Above that layer, one porous separator. Above that layer, nickel hydroxide layer. Above that again porous separator. Again cadmium hydroxide. Again porous separator. Again nickel hydroxide and so on. Right? So it will have layers by layers. Observe. Clear? Understood or not? So as such, layer by layer you will get. So it is rechargeable. Rechargeable nickel cadmium cell is a jelly roll. Are you able to understand why we call it as jelly roll? Why you call it as jelly roll? Arrangement, jelly roll arrangement, and is separated by porous diaphragm. And separated by a porous diaphragm, right? One layer is present, one layer is having cadmium hydroxide, another layer is having nickel hydroxide. Means porous diaphragms dipped in cadmium hydroxide, another porous diaphragm dipped in nickel hydroxide, one more porous diaphragm not immersed in both. Are you able to understand? So separated by a layer soaked in moist NaOH or KOH. Right? Any questions, sir? Means one layer of cadmium, another layer of nickel oxide. In between both layers, I have kept sodium hydroxide layer. Sufficient, na? Response, sir. So this is nickel cadmium cell. Next cell, sir. Addition, na? Addition cell. Fuel cell. Oh, addition cell is not there. Addition cell is there. There, 1 minute. Addition cell not there. But I remember, maybe while you are solving numericals, you may find it. One more cell called addition cell, or we call it as nickel iron accumulator. Let me write as 5th type. Addition storage battery. Addition storage cell, or we also call it as nickel iron accumulator. Observe this cell representation, sir. Iron interface, iron oxide interface, KOH aqueous, salt bridge, again KOH aqueous. So both cells have KOH aqueous. That's why I have removed salt bridge. So KOH aqueous, interface, Ni2O3, interface, nickel. Are you able to understand? Understood or not? Now, coming to anode. Now tell me which acts as anode? Which acts as anode? Iron. Which acts as cathode? Nickel. So what happens at anode? Oxidation, no? So Fe with 2 OH minus aqueous gives rise to form FeO plus H2O plus 2 electrons. Now cathode. Nickel, Ni2O3, nickel oxide plus H2O plus 2 electrons gives rise to form NiO solid plus 2OH minus aqueous. Check whether the reaction got balanced or not. Now observe the overall reaction. Observe the overall reaction, sir. Iron, 2OH minus, 2OH minus, H2O, H2O, 2 electrons is gone. So plus Ni2O3 gives rise to form FeO plus nickel oxide. Response, sir. Okay, 2 Ni. Done. Addition cell, or we call it as nickel iron accumulator. Response, sir. Next, one more cell is there. Lithium ion batteries. Our batteries, daily use batteries, mobile phone battery, right? So lithium ion batteries are simply lithium batteries. In this, lithium acts as anode. MnO2 act as cathode, or you take any metal oxide or any metal hydroxide. Till now we are taking zinc oxide, HgO, Ni2O. Response, sir. Ni2O3 or FeO. Right? So only we are taking metal oxides now. One is taking one metal we are taking, and one respect to metal oxide we are taking, right? So same way, Here I am taking lithium anode and some metal oxide or hydroxide we are taking it as cathode, right? Or we can take sulfite also. This can act as cathode. Whatever I am taking, whether it is any oxide or hydroxide or sulfite, whatever it may be, it has to be accumulated with lithium plus ions. Right? So they have to be incorporated with Li plus, lithium plus. Right? So this will act as cathode. Now, some electrolyte must be there. So some aqueous soluble salt solution of lithium should be taken as electrolyte. So generally we will take lithium chlorate, LiClO4, which is dissolved in some organic solvent. Right? This is taken as electrolyte. Now observe the cell reaction. What happens at anode? Already we know what is anode. What is anode, sir? So can I write lithium gives rise to Li plus plus electron. Now which acts as cathode? Any metal oxide. So can I take MnO2? So I'm writing MnO2 solid, which is acting as cathode, plus Li plus plus electron gives rise to LiMnO2. Right? Now do this metal oxide is incorporating lithium or not? It is accommodating lithium or not? Right? Now what is the overall reaction? What is the overall reaction, sir? Lithium with MnO2 gives rise to Li plus gone, electron gone. Respond. And what is the output voltage? Approximately 3 volts. Now, fuel cells. Fuel cells already we discussed in hydrogen compound chapter, if you remember. Hydrogen and its compounds chapter. Just a moment. 24, 25 batch, class 11th. Hydrogen. Fuel cells. At cathode, we are passing oxygen. At anode, we are passing hydrogen. And base is taken as electrolyte. KOH aqueous or NaOH aqueous is taken as electrolyte. Response, sir. Right? So same thing I am writing here. Fuel cells. Right? So can I write the seventh type of? Observe. Here, whatever we are passing, we are keep on passing hydrogen gas, right? Means this membrane is in touch with hydrogen gas. That side, that membrane is filled touch with oxygen gas. In between, what is present? Some electrolyte, maybe acidic or basic. So I am taking OH minus, or we can take H plus also, your choice, right? So I am taking base, right? Now, what happens? Which is acting as anode? Just now we have seen, man. Which acts as anode? Oh, this one. Just a moment. Which acts as anode? Where we are passing H2
O2.
gas, that is acting as anode. So this part where we are bringing hydrogen gas, where we are passing hydrogen gas, that part is acting as anode. So I am writing that hydrogen anode. What happens? H2 gas plus 2OH minus aqueous gives rise to 2H2O plus 2 electrons. Do the reaction balanced or not? Whereas where we are passing oxygen, that acts as cathode. Respond, sir. Visible properly now? What I will write? O2 gas plus 2H2O plus 2 electrons, or I will write, can write half O2 plus H2O plus 2 electrons gives rise to 2OH minus aqueous. Check whether the reaction got balanced or not. Oxygens 2, hydrogens 2, charge 2 minus 2 minus. What is the overall reaction? H2O, H2O, 2 electrons, 2 electrons, 2H minus is gone. So what is the overall reaction? H2 gas plus half O2 gas gives rise to H2O. Right? And what is the voltage output of this cell? Approximately 0.9 volts. So this cell has some benefits. Not only producing voltage, it is producing water also. So this will be useful for needs of astronauts in spacecrafts, where fuels are used for production of electricity, as well as output water is used for survival. Clear? Respond. Here, expected voltage or expected efficiency of this cell expected to be approximately 95% efficient, but output efficiency is approximately 65%, 65 to 70%, right? And its operating temperature is from 70 degrees centigrade to 140 degrees centigrade. Operating temperature is also reasonably high. This is about fuel cells, right? Any other given? Check. Page number 130. Done now? Hydrogen oxygen fuel cell is used in spacecrafts as a source of electric power. That's all. Combustion of fuels such as H2CO, methane can be converted directly to electrical energy in fuel cells, right? Here I am taking hydrogen oxygen. So instead of that, we can also use what they are saying: CO, methane, etc. can be used for generation of electrical energy. Response, sir? By combusting them, we are creating electrical energy. Right? So this is about fuel cells. Next, sir. What is next slide? Corrosion. Last topic of this chapter. Right? So corrosion. What do you mean by corrosion, sir? What do you mean by corrosion? Interaction with atmospheric condition. If a metal gets oxidized, we call that as corrosion. So can I call it as oxidation or deterioration? Destruction, right? So deterioration of metal, deterioration of, just a moment. Hello? Just a minute. 1 minute. Last one. Okay. Deterioration of metal due to environmental conditions is called corrosion. If it is iron metal converts into iron oxide, we call that process as rusting of iron. In case of iron, we call it as rusting. So what you will get? You will get iron oxide, Fe2O3.XH2O. If it is silver, what we call it as? Tarnishing of silver. Right? Silver converts into silver sulfide. If it is copper, what do we call it as? Patina. Right? Patina of copper. You will get that green color. If you store water in copper beakers, you will see some green color layer. Right? So that is nothing but due to formation of malachite or azurite. Malachite. These two are ores of copper. Malachite and azurite. Right? CuCO3.CuOH twice. Or 2CuCO3.CuOH twice. These two are important ores of copper. Right? So interaction of metal with environmental conditions, mostly with oxygen or moisture to form respective oxides, is called oxidation. So in which first we will see purely about iron, rusting of iron. So I am taking side heading rusting of iron. Online, anyone alive?
Yes,
No one is
sir.
responding.
Yes, sir.
Understanding or not? Remaining students.
Understand, sir.
Right. Now coming to rusting of iron. So I am assuming one iron surface on which a drop of water is present. So I will take that image directly. We call that as differential oxygen method. Rusting of iron is explained by differential oxygen method. I will take that image. Mhm. Differential oxygen method. I am taking this image, sir. Now see this. So this is iron surface having some, it is not polished iron surface, some cracks or some dents are present, right? Rough iron surface on which a droplet of water is present. If it is a smooth surface, rusting doesn't happen easily. If there is a dent or crack or any distortion on metal surface, then that metal surface, such metal undergoes oxidation readily, right? Now here I am separating this into 3 compartments. Some middle compartment and terminal compartments. So I am separating this into 3 parts. Middle part, these 2 are extreme parts, right? So 3 parts, in which in middle part it acts as anode. Middle part act as anode, whereas these end parts act as cathode. Any questions in it? Right? So what happens in anodic part? What happens, sir, at anodic part? What happens? Oxidation only. So iron which is in contact with water droplet undergoes oxidation. So why it has to undergo oxidation? In these 2, where surface area is high. But if I take a drop of water, this is surface, I am taking a drop of water on the surface. I have separated that into 3 parts. Where surface area is more. Here surface area is less, observe carefully. This is the surface area here, this is the surface area here. Where surface area will be high? Extreme. Means amount of water coming in contact with oxygen, atmospheric oxygen. Right? More air comes in contact with these 2 parts. If more surface area is there, more amount of atmospheric oxygen is soluble here. So concentration of O2 is high here and it is low here. Correct or not? Right? So where oxygen is in contact, this O2 can react with H2O to form 2OH minus by gaining 2 electrons. Check whether the reaction balanced or not. Means what happened? Oxidation or reduction? Reduction means, can I call this as cathodic part? That's what I am saying, cathode. Right? So here it is gaining 2 electrons, means somewhere it has to lose electrons. So the middle part, this is iron now. This iron goes into solution as Fe+2 by leaving electrons. Right? Those electrons will move from here to here. Circuit is closed. Response, sir. Right? So in middle compartment, iron is converted to Fe+2, means in middle compartment what happened? Oxidation. Means middle compartment is acting as anode. That's what I'm saying. Response, sir.
Yes, sir.
Right? Now, atmospheric carbon dioxide, if it dissolve in water, it can form H2CO3, which make solution acidic. If atmospheric oxygen is dissolved more, it makes a solution basic. Whether formation of acid or base, both will catalyze oxidation of metal or rusting of iron. Is it clear? So iron which is in contact with atmospheric air, right? In contact with, can I say dissolved? Why I'm saying dissolved? Water in contact with atmospheric gases, right? Dissolved carbon dioxide or dissolved oxygen can undergo oxidation. Both acidic medium as well as basic medium both acidic medium as well as basic medium, both will enhances rate of corrosion. Clear? So corresponding reaction I am writing. Fe converts to Fe plus 2 plus 2 electrons. Response, sir?
Yes,
Right?
sir.
So what is this is oxidation process. What is E of oxidation? We have one table now. Check the table. What is E of oxidation? What is E naught of Fe converted to Fe plus 2? What is that value? Fe converted to Fe plus 2. Plus 0.44 volts. Or there it is reduction given. Fe plus 2 to Fe given. Minus 0.44. We are taking oxidation. So plus 0.44 volts, right? Response, sir. So these electrons which are lost here can be taken by oxygen. Or earlier we have shown. Right? If it is taken by oxygen, you will get OH minus. Correct? Or it may be taken by H plus also due to H2CO2 dissolved in water to produce H2CO3. So you'll get H plus ions now. So that liberated electrons can be taken by H plus also. Understood? So these electrons which are released here, these electrons which are released here or electrons lost here can be absorbed by either H plus or O2, right? So if it taken by H plus, from where I got this H plus? From where I got this H plus? Due to atmospheric carbon dioxide, correct? Can I write this? Do you have any questions in it? Now, these two H plus ions gain electrons to form nascent hydrogen. This hydrogen may combine with atmospheric oxygen to form H2. Now observe overall reaction. What is this overall reaction now? Half O2 plus 2H plus 2 electrons gives rise to H2O. Now check what is E naught value of it. See the table. What is E naught value of this? O2 plus 2H plus electrons gives rise to H2O. What is E naught value?
1 point.
Plus 1.23 volts. Response, sir. Check it.
Yes, sir.
Check the table. O2 plus 2H plus electrons gives rise to H2O. Okay, H2O gives rise to half O2 plus 2H plus electrons. Correct? Same thing or not? 1.229 volts. Yes, yes. 1.229 volts means approximately equal to 1.23 volts. Right? So this is what happens at anode. Right, sir? Now, what is the overall cell reaction? What is the overall cell reaction? Therefore, add both. What is the overall cell reaction? Iron,
2F.
right? Plus half O2 plus 2H plus 2 electrons gone gives rise to Fe plus 2 aqueous plus H2O. All right? This is the overall reaction. This is anode, loss of electrons. Here it is gaining electrons now. So this is cathode. So this is cathodic reaction, that is anodic reaction, both put together. Cell reaction is done. So what is the overall voltage output? What is E of cell or E naught of cell? What is E naught of cell now?
1.67.
1.23 plus 1.44.
1.67.
1.67 volts means a rusting of iron is nothing but battery which can generate 1.67 volts. Means from external source, if I connect another battery having voltage greater than 1.67 volts, what happens? Cell reaction should get reversed. Means rusting of iron will not happen. When iron is converted into iron plus iron oxide, it is liberating 1.67 volts. If E external is greater than E naught of cell, cell reaction should reverse, no? Means forward reaction doesn't occur. So rusting of iron can be stopped. Respond, sir. Any questions? I am writing the same point.
No.
I am writing the same point. If E external in this cell, if E external which I have connected is greater than or equal to 1.67 volts, if E external is greater than or equal to 1.67 volts, what happened? Then rusting of iron can be stopped. Acceptable or not? Say something, sir. Right?
Yes, sir.
Now, instead of carbon dioxide, if the amount of oxygen dissolved in water is high, then if carbon dioxide dissolved is high, you got H2CO3, therefore solution became acidic, therefore this reaction happened. Instead, if atmospheric oxygen dissolved is high, what happened? If a dissolved oxygen is more, what happened? What happens, sir? If dissolved oxygen, so can I write the reaction as half O2 plus H2O plus 2 electrons gives rise to 2 OH minus aqueous. So the reaction balance out. Just now we discussed, man, if a CO2 dissolved is more, you will get H2CO3, which produces H plus. H plus ions will gain electrons. If a dissolved oxygen is more, then oxygen will gain electrons to form OH minus. Solution become basic. Their solution is acidic. So acid as well as base both will catalyze rusting of iron. Respond, sir. Any questions in it? So dissolved oxygen may
No.
gain electrons. Can I write to form OH minus aqueous? This is the reaction, right? Now, what is the voltage output here? Check. What is the voltage output? O2 plus H2O plus 2 electrons gives rise to 2 OH minus. Check the reaction. What is the voltage output, sir?
1 point.
Hmm. Hmm. 1 point. 1.8.
Yes, sir. Correct, sir.
1.75. Yes, man. This is H2O2. I'm saying O2 plus H2O plus 2 electrons gives rise to 2 OH minus. That is from H2O minus 0.828. Not there, ma'am. This is use H2O2, right? This is H2O2 to H2O. 0.69. But there is no OH minus, ma'am. Observe this one. Which one?
Both first.
Oh, they gave up. How much? Hmm. Or they have given only H plus 8. Correct now? So I'm taking this one, sir. Copper plus 2 copper, that is plus 0.52. Huh? Here, copper plus 2 copper plus 1. This is copper with iodine, that is copper plus 2 copper plus 0.34. Right? Here. Compare these two. These two. Copper plus 2 converted to copper plus 1. Copper plus 2 to copper plus 1. H2O converts to OH minus. Here it is plus 0.15. This is minus 0.15. Right? So I am reversing this and I am adding that here. Then what happens? Copper plus 1 gone, plus 2 gone. So overall, it converts to OH minus. So what is the voltage approximately? 0.3 volts. Is there any other? Check, sir. Is there any other reaction with the exact voltage or exact reaction given? Reduction potential of O2 to OH minus. Here, see that basic pH equal to 14. What is the voltage, sir? O2 plus H2O plus 4 electrons gives rise to 4 OH minus. So what is that voltage? Plus 0.4 volts. See this one, sir, basic solution. So approximately 0.4 volts. Acceptable, sir? Are online someone respond, man?
Yes, sir.
Clear? I am talking about this reaction, not all, only this one. Whether this and this both are same or not. Right? So what is this one?
Yes.
Plus 0.4 volts. Done? Say something, sir. Right? No.
Correct, sir.
So whether I have taken either acidic or basic, anyhow, both cases, whatever it may be. Right? What happened in total? Iron converted to Fe plus 2. Right? And those electrons will be gained either by acidic medium or by basic medium. among these two, where E naught of cell is high, whether it is in acidic or basic, where E naught of cell is high, right? Means which will favor reduction more readily, acidic medium or basic medium? Where E naught is more positive, delta G becomes more negative. So rusting of iron is more favorable in acidic medium than basic medium. Are you understood or not? Say something, man. Right?
Understood.
So we can write few more reactions also. Right? So I am taking one more note. Observe this reaction. So they have given one more reaction, na? Iron plus 2 with the O2. They gave one reaction, na? That's no way of it. Right? That I am right. So Fe plus 2 plus O2 gives rise to plus H2 also. Huh? So plus H2O gives rise to nothing but I am adding this reaction and this reaction. I am adding this and this. So then what do you write? Right? Fe with O2 gives rise to Fe2O3 plus H plus. Those are 6, so I will write as a 4. Here 4 means balanced. Reaction got balanced. Now this Fe2O3 will absorb moisture or will react with water to form Fe2O3 dot XH2O. This is what we call it as rust. Done, sir? This is about corrosion, right? Now, how to stop corrosion? So I am writing that point. Factors affecting corrosion. Factors affecting corrosion. Already you know one factor. One factor you know. If E external becomes greater than E naught of cell, that is greater than 1.67 volts, then obviously corrosion will be stopped. Or if it is 1.67 volts, that is stopped. Here voltage will be even less than that now. Here what is the voltage if it is oxygen? 0.44 plus 0.8884 ohms. Right? 0.84, here it is 1.67. So if external battery is more than 1.67, both reactions will be stopped now. Right? Response, sir. Now, second condition. What is oxidation potential of iron? 0.44. If I take another metal having oxidation potential greater than 0.44, then which will undergo oxidation? This is 0.44. If I take another metal having voltage greater than 0.44 volts, then among iron and that metal, which will undergo oxidation readily? Other metal. So we call that metal as sacrificing metal. Clear? So if you take any metal with oxidation potential, metals with oxidation potential greater than 0.44 volts, right? If metals with E naught greater than 0.44, they will act as sacrificing metals. Reason why we call them as sacrificing metal? Reason, compared to iron, these metals undergo oxidation readily. We will write oxidation, undergo oxidation instead of iron. Any questions? Right? And that potential applied, we call that as sacrificing potential. So what is the sacrificing potential for protecting iron greater than 0.4. So we call this as sacrificing potential. Response, sir. Or we call it as sacrificial protection. Can I call it as protection or not? By applying this much voltage, I can stop oxidation. So I can do protection. So sacrificing protection, sacrificing metal, sacrificing potential. Respond. Right? For example, if iron metal is connected with zinc rod, then what happened? Or if iron is coated with zinc rod, what happened? Iron coated with zinc. What we call it as galvanization. We call that process as galvanization. Then what happened? What is reduction potential of iron? What is the reduction potential of iron? Minus 0.44 volts. Oxidation potential is 0.44. Now, what is E0 reduction of zinc? Minus 0.76 volts. Among these two, which will undergo oxidation readily? Zinc. So, during galvanization process, zinc will undergo oxidation, protecting iron. Zinc will not allow iron to undergo oxidation. So, rusting is stopped. Clear, sir? Response, sir. Response, sir. Any questions in it? Now,
No,
if
sir.
zinc undergoes oxidation, zinc converts into Zn+2. It will combine with atmospheric moisture to form zinc hydroxide, which can absorb carbon dioxide to form zinc carbonate. Correct or not? Means if I use zinc, I will not allow atmospheric carbon dioxide to dissolve in water. So solution can't be acidic. Correct? Reason? Zinc will react with carbon dioxide, no? So solution can't be acidic. So rusting of iron is completely stopped. Clear? So zinc will combine with that atmospheric carbon dioxide, forming a protective invisible layer. Yes, sir. We call it as basic zinc carbonate, sir. Why we call it as basic zinc carbonate? Because it forms ZnCO3 dot ZnOH twice. Basic zinc carbonate. That's how rusting of iron is stopped. Right? If E0 reduction is more negative, what we call them as? More electropositive metals. Right? So that is more electropositive metals. More electropositive metals prevent rusting of iron. Response, sir. Example: zinc, magnesium, aluminum, etc. Any questions in it? Now, second, if you have water droplet on the surface of iron, then only rusting happens. If iron will never come in contact with water, means if you coat this with oil or grease or paint, then so second point, coating iron surface or coating metal surface with oil or grease or paint or copper or tin or metal oxide etc. They can stop corrosion. We call that as barrier protection. We call this as barrier protection. So via barrier protection also we can stop corrosion. By sacrificial potential we can stop corrosion. By barrier protection also we can stop corrosion. Sacrificial potential, sacrificial protection, barrier protection. Any questions, sir? Now, point number 3. Instead of that, if the surface itself is polished, if there is no dent or crack or anything on the surface, then what happens? Corrosion will be slowed, right? So, or it will take more time for corrosion. So, less surface area. So, avoiding dents, or cracks over surface. Right? This also will stop corrosion, right? Instead of that, if I create dents or cracks, then if I create dents or cracks over the surface, it's promote corrosion. That's why lifespan of vehicles will go down. Lifespan of ships also goes down. Just if you keep a scratch over the surface of it, hull strength will decrease over time. Correct? Presence of electrolytes means solvent. We are providing basic medium or acidic medium. If I bring acidified water in contact with iron, then what happens? Corrosion gets enhanced. Correct? So presence of electrolyte will enhance corrosion or not? Response, sir. Presence of moisture.
Yes,
Presence of moisture or moisture air. Right? Response, sir. Presence of impurities in the metal. All these factors, what they will do? All these factors can enhance corrosion. So they may promote corrosion. Therefore, all these should be avoided. Any questions in it? Response, sir. Now, one more important point given in your textbook. Last point in your textbook, sir. Phosphates. For corrosion, one point is there. Phosphates called as anti-rust solution. Correct? Respond, sir. What is that anti-rust
yes,
solutions? Anti-rust solutions. What is it? Alkaline phosphates and alkaline chromate solutions. Right? They also stop corrosion. Why? When you are providing alkaline basic medium, then what happens? Generally, acids will enhance the rate of corrosion. Bases will remove that acidic H plus. If they remove that acidic H plus, corrosion slows down. Right? So they prevent availability of H plus ions. Right? And also these phosphates as they are less soluble in water, they form one layer on the surface, right? It prevents availability of H plus ions and form insoluble thin layers. Example. Major problem in vehicles is radiators damage, right? In order to cool engine, there will be a radiator present in front of vehicles. Fans will be present. They will continuously blow air over the engine. Correct or not? Right? Of course, coolant will be there. Coolant is different, right? In addition to that coolant, this will keep on blowing air over the engine so that temperature will be controlled, right? So during wear and tear, they may get corroded. So you may get holes in the radiator. Correct? If you have holes in the radiator, if it is oil cooled or liquid cooled radiator, what happens? Always that coolant will be leaked out. So it is impossible to cool the engine. So major problem in radiators is having, because of corrosion, you will get holes. So that's why they will always coat radiators with basic metal phosphates, right? So because of it, even rust happens, that rust will be precipitated as iron phosphate, right? So that's why observe that statement, what they have given. Particularly it is used in car radiators to prevent rusting. Right? Done. On the page. Exercise on. So next question, sir. So page number 132 is done. 132 or 133? Yeah. Right? Now we also go for numericals. See this, sir? Mercury cell, fuel cells over, corrosion part is over, and this point is also over using rust solutions. Electrical protection, cathodic protection already done by coating with the other metals. Galvanization over, sacrificing protection over, barrier protection over. Now coming to this. So from question number 15 to 20. Yes, sir. Yes, yes, sir. Go, sir. Solve this question number 15. Which of the following cell is a secondary cell? Secondary cell means rechargeable. Which one? Nickel? Next, sir. Nickel cadmium, actually. They rate as NiCd. Correct? Next, sir. In lead storage battery, anode is lead acts as anode, lead oxide acts as cathode. Just now we have seen, man. Lead acts as anode, lead oxide acts as cathode. Which one? Second option, anodic reaction. No. Third option. Depolarizer used in dry cell batteries. Mn wood. The reaction H2 plus OH minus fused to H2 plus 2 electrons occurs in hydrogen oxygen fuel cell. This reaction occurs at hydrogen, man. anode. Are oxidation reaction, na? So this reaction here, anode. When iron is rested, the final product formed has iron can be prevented from rusting by connecting iron to more electropositive metal. It is called cathodic protection. Is it cathodic protection or anodic protection? Connecting iron to more electropositive metal, anodic protection. Connecting iron to less electropositive metal, connecting iron to less electropositive metal. Connecting iron to more electropositive metal only, no doubt, right? Then what happens? That metal undergoes oxidation. So then it is anodic protection or cathodic protection. Correct or not? Check. Huh? Anodic protection, huh? Why? That metal acts as anode now. Iron acts as cathode, na? Iron, metal. Among these two, which will undergo oxidation readily? Metal undergoes oxidation readily. Means that metal is acting as anode. Means iron acts as. So which is protected? Cathode is getting protected, na? Response, sir. Next, sir. So all these things are over, right? Lithium, here it is there, sir. Lithium batteries. All this discussion is done. Step 1, anyhow, you will solve. In step 2 also, most of the star mark questions we have already solved. Right? They say something, sir. Star mark questions, question number 17, in up to which question we have solved star mark questions. Oh, almost all star mark questions we already solved, man. Right? Question number 17 solved or not? Wait. Question number 3, star mark question. Where? It's not here, man. Yes. Okay, question number 3 we have not solved, I think. Question number 52, 85, 49, 90. Solved, huh? Then where is it? Okay. We have confidence, okay. Question number 7, 9, 8. Question number 8. Not a? Then we will solve. Solve it. During electrolysis of aqueous solution of a salt using inert electrode, pH in the space near one of the electrode is increased. Which of the following salt? Solved, I think. Huh? 9th also is solved. First question is 9th only in this book. pH near one of the electrode is increased. pH is increasing means solution is becoming basic. Correct? Where solution becomes basic? KCl? KCl or not? If you take KCl aqueous, what happens? At cathode, H2 is gone. At anode, Cl2 is gone. What is left? KOH is formed, na? So solution becomes basic. So, sir, yes, sir. Yes, sir. Yes, sir. Now itself. Actually, I'm in class now. Okay. No, there many students are there. We kept only few students in that photos. Many students are there from CUA. This year also we have in my class now in front of me also many CUA students are present. Aditya is from CUA. Yeah. Yogita is also our student only. Yes, sir. Yes, sir. Many are there. Okay. Yes, yes. I will do it. But actually, right now I am in class. Huh? Next. Right, sir. Right, sir. Last year we have 74 selections, na? We cannot keep 74 students in front page. This year, you don't ask. I will directly, I am accepting. This year, advanced also, I am not expecting anything. Means you may get few selections. Last year result was very good. Best rank is of 590. I don't remember exactly. 500, less than 600. That I remember. 595 or maybe something. Advanced also good rank only. Close to 1500 open category. He got IIT Delhi. He's studying in IIT Delhi. Karthik Agarwal. Right. Before that year also means 2022 also we had very good result. Right? Leave it. Come to this. And again, I am expecting good result from your batch. Reasonably good result. Question number 13 solved. 1-3. No? Right. We will solve it. Solve this one. 13. In electrolysis of aqueous solution of NaOH, 2.8 liters of oxygen at NTP was liberated at anode. How much hydrogen was liberated at cathode? We were doing electrolysis of aqueous NaOH now. Right? So NaOH means what are cations available? Na plus aqueous and H plus aqueous. Anions available. OH minus aqueous. Here I will take OH minus directly because solution is basic. Correct? Sir, then if it is base, why you are taking H plus? Don't take H2O. But problem is what you have to do? From H2O, I need to do. Cations go towards cathode. Right? So, and they gain electrons. Correct? So, I will write that in this way. At cathode, I can write reactions in this way. 2H plus gain 2 electrons to produce H2 gas. Or I will write the reaction this way. H2O gain 2 electrons to produce OH minus I have to write, man. So shall I write that as solution is basic now, so OH minus I will write that in this way then. So I should get 2 OH minus. If I want to write 2 OH minus here, what I will write? H2O plus half O2, can I write? Can I write in this way? Gain of electrons, na? Right? Means I am taking oxygen, but there is no oxygen present in the solution. How I will take it? This is no doubt nothing but reduction reaction only. But there is no O2 in the reaction, na? O2 will be liberated, O2 will be generated at anode. Say this. At anode, 2 OH minus gives rise to H2O plus half O2 plus 2 electrons. Do the reaction got balanced or not? So O2 is liberated at anode, but there is no O2 present. So I cannot take this reaction. So change it. Change the reaction, sir. Change the reaction. I need to prepare H2 from H2O. How I can prepare H2 from H2O? By adding electrons. How I can do it? Response, sir. How I will write it? Other than this, what we can write? Is there any other possibility? I will need to use H2O by adding electrons and I need to produce H2 man. This is the reaction I have to write. Right? How to do it? I am writing H2. Where is oxygen? I need to remove oxygen. How to remove that oxygen? How to remove that oxygen? I have to remove that oxygen to the form of O2. Then I have to make the electrons to be gained. If I make the electrons to be gained, I can write O minus 2. Right? Correct or not? So for that I am writing 2H2O and I will write 2OH minus. Check whether the reaction balanced or not. Balanced or not? Means if I want to eliminate above H plus, I will do this reaction. Sir, why you are not preparing this? Solution is basic, no? And solution is basic. What about availability of free H plus? That free H plus will convert into H2O. But it has to gain electrons. So if H2O gain electrons, it is producing H2. Or if H plus gain electrons, it is also producing H2. Means overall, when it is gaining 2 electrons, I am getting 1 mole of H2. Here also, it is gaining 2 electrons to produce 1 mole of H2. So any of them is same only, no? So that's why either I will write this or this. Both you say. Now here, 2 electrons are giving half O2. Correct? So number of moles of gas liberated at cathode is double the amount of gas liberated at anode. And at anode, if you are getting half O2, at cathode I am getting 1 H2 by using same number of electrons, 2 electrons, 2 electrons. Correct? Response, sir. Now what they are saying? 2.8 liters oxygen is liberated. Then what is the amount of H2 liberated? Double of it. Response, sir. Correct or not? Any questions in it? Right. Next. 17. Done? Not solved, huh? And from where we solved all these star mark questions, ma'am? Question number 6, 10, 13. 16, 9. From where all these questions are? 13, 72, 75, 124, 130. From step 3, yeah? Step 2 only. Okay. Huh? Okay. Right. Let it be. Question number 17. 1 molar aqueous solution of NaCl undergoes electrolysis if 50 milliampere current is passed for 12 hours. Assume current efficiency is only 25%. Total volume of gases liberated at standard state is. You are taking NaCl aqueous. Do they mention dilute, very dilute, anything? Right? If they mention very dilute, at anode, what I will do? Oxygen I will liberate. Otherwise, I will liberate chlorine. Right? So, what happens at cathode? What happens at cathode? 2H plus, gain 2 electrons to produce H2. Response, sir? Say something. Now at anode, sir? 2Cl minus gives rise to 2 electrons plus Cl2 gas. During electrolysis, what happened? pH increases. Reason? Due to formation of NaOH. Yes or no? Aqueous NaCl. What are the cations available? What are the cations available? H3O plus and Na plus. Correct? What are the anions available? Cl minus and H2O. Don't write OH minus. Enthalpy of OH minus is formation of OH minus is not 0. Enthalpy of formation of H plus is 0. We discussed it or not? Right. Now, at cathode, this is gone. At anode, this is gone. So what is left? Na plus and H2O, which is forming NaOH. Therefore, pH increases during electrolysis. Now, what they are asking? What is the amount of charge passed? What is the amount of charge passed? What is Q? I into what is T? 12 into 60 minutes into 60 seconds. If I divide this with 96,500, then I will get Faraday. Otherwise, I will get coulombs. I into T, you will get coulombs. If I divide it with 96,500, I will get Faraday. Right? This much Faraday I am using. So what is this value? Two zeros are gone. Right? What is the value? 50 into 12 into 6 into 12 12s are 144. Huh? Oh, so that is 36. Huh? So 50 into 36 into 12 divided by 965. That is 22.38 into 10 power minus 3. Right? So this value is 22.38 into 10 power minus 3 Faraday. Means these many moles. For 2 moles of electrons, I got 2 electrons used here, 2 electrons liberated. Total electrons used is 2. For 2 electrons, I got 2 moles. For 1 electron, I will get 1 mole. For these many Faraday, for these many moles of electrons, same moles of gas liberated. Right? So these many moles means into 1 mole means 22.4 liters, but given efficiency is 25, means into 0.25, 25% efficient. So into 0.25 into 22.4 liters. You want in ml. So into 22,400 ml. Correct? Right? So I got that as 125,347 into 10 power minus 3. So I will write as 125.347 ml. 125.347 ml means answer is option 3. I say something. Correct or not? What is the formula? Faraday's Faraday's first law of electrolysis. Weight equal to atomic weight upon n factor into Faraday into I into T. I in amperes, T in seconds. Correct? Huh? Response, sir. Instead of weight, if I want to write volume, then instead of atomic weight by n factor, I will write molar volume. Correct? So what is that molar volume? 22,400 ml divided by n factor. Correct? Huh? Response, sir. Correct or not? What is the efficiency given? 25% efficiency. Correct? So into 25 by 100 efficiency. Say something. So that's what I'm using. 22400. What is n factor? 2 Faraday 96,500 into I value 50 into 10 power minus 3 into T 12 into 60 into 60. Right? This total thing into 25 by 100. Right? I'm writing the 25 by 100 here. Correct. I say something, sir. Right? Same thing I'm writing. These two zeros gone. These two zeros, 0, 0 gone. Oh. 0 and this 0 gone. So what is left? 25 into 224 divided by 2 into 965 into 5 into 12 into 36 into 10 power minus 2. Correct? Huh? Hey, 50, man. 50, I wrote it as 5. Na? Correct? Huh? So I am doing the same. 25 into 224 into 5 into 12 into 36 into 10 power minus 2 means I am writing divided by 100 divided by 2 divided by 965. Oh, I am getting 62.67, man. Correct one. For 2 electrons, I am getting 2 moles. 1 mole at cathode, 1 mole at anode. Correct? Response, sir. So I am getting 2 moles. Means I need to multiply the value with 2 also. Correct or not? For n factor, I have taken 2, no issue. But volume of gases liberated is 2 moles, na? So what is n value? Per mole it is 1 only, na? Correct or not? So I am multiplying this value with again 2. Correct? So then what is the value? 62.67 into 125.347 is the answer. Response, sir. So V of gas is equal to 25 by 100 into 22400 upon 2 into 96500 into 22.38 into 10 power minus 3. Then I will not write this also. Over. Clear? Next question, sir. 17 is over. 19? 19 done? No. Question number 19. What they are saying? Zinc amalgam is prepared by electrolysis of aqueous ZnCl2 using 9 grams of mercury cathode. How much current is to be passed through ZnCl2 solution for 1000 seconds to prepare a zinc amalgam with a 25% zinc by weight? In zinc amalgam, weight of zinc must be 25%. How to prepare it? How much mercury, how many grams mercury you have taken? 9 grams, right? Mercury is already 9 grams. What is percentage weight of zinc in it? Percentage weight of zinc is equal to weight of zinc by total weight into 100. Response, sir. What is given? 25. Weight of zinc, I don't know. Let it be X. Then what is weight total? X plus 9. The zinc weight is X. Already mercury weight is 9. So total weight is X plus 9 into 100. So can I write this as 4 times? Bring this to this side. X plus 9 equal to 4x. Bring this x to this side. 3x equal to 9 means x equal to 3 grams. So what is the weight of zinc deposited? 3 grams. So to deposit 3 grams of zinc by passing current, I don't know, I, time is 1000 seconds. Problem solved. Apply Faraday's law. Weight of zinc is 3. Atomic weight 65.4. That also they gave. Correct? Divided by n factor 2 into 96,500. Correct? Huh? Faraday. Into I value, I don't know. Into time, 1000. Respond. So can I cancel these 2 zeros and these 2 zeros? So what is I value? Bring this to this side. 3 into 2 into 965 divided by 654. 65.4 into 10. Right? So 654 means this is 2, that is 3. 9, 9 2s are 18, huh? This is 650, man. This is 960. This is approximately 2 times. This is approximately 3 times. 2 gone. 3 3s are 9. So answer must be slightly less than or slightly close to 9. Say something, right? Or we will do it. 6 into 965 divided by 654. Answer is 8.85. Right? Done. Next question, sir. 19 over 21, 22, 28, 30 shall we solve? 27 also. 27 done or not? I think 27 is solved, man. Here. Not done, huh? Okay, 27 also we will see. 27. And what those questions, man? Okay, 27 solve. Yes, draw a Latimer diagram. Can I draw a Latimer diagram in this way? Copper plus 2 gives rise to copper plus 1, gives rise to copper, and from copper plus 2 to copper directly. What is potential for copper plus 2 to copper plus 1? Copper plus 2 to copper plus 1. They have given. What is it? Plus 2 to plus 1. 0.153 volts. Plus 2 to copper. Plus 2 to copper given as 0.337 volts. Sponsor. What is this E? Let me write it as E only. What is N value? I am writing N1 equal to 1 here. N2 equal to 1. N3 equal to 2. What is the formula? N1 E1 plus N2 E2 upon N3 equal to E3. Sponsor. E3 naught equal to N1 E1 naught plus N2 E2 naught upon N3. Correct? Correct or not? Now what is E3 naught? 0.337. N1 is 1, E1 not 0.153, N2 is 1, this is E divided by N3 is 2. Bring this to this side. What is that? 7 2s are 14, 1 3 2s are 6, 7 6. So 0.674 minus 0.153. What is that value? 4 minus 3 1, 7 minus 5 2, 6 minus 1 5. So answer 0.521 volts. Respond, sir. Correct or not? Next question. 27 over 28 to 30. So this question number 30. Array, you are simultaneously checking the answers or not? Solve this question number 30. Done. What's pH given means concentration of H plus given. Is it oxidation reaction or not? First check. Is it oxidation reaction or not? Right? For that E naught is given. What do you want? E. Then next equation. What is it? E oxidation equal to E naught oxidation minus 0.0591 upon 2 into log of concentration of product by reactant. What product side? H plus square. Response, sir. What is E naught oxidation given? 1.3, 0.0591. I am writing upon 1 only. Because this log H plus square, I am writing 2 log H plus. Right? 2 gone. Right? And I will write this also as plus. And I am writing minus log H plus as pH. This is, I am writing plus and I am writing it as minus log H plus. Minus log H plus means pH. What is pH? Over. So 1.3 plus 0.3 ones are 3, 9 threes are 27, 2, 15, 15 plus 2, 17, 1. Correct? Say something. So 3, 7, 7, 4, 1. So 1.4773. Done? Next question. 32. Solve. Again, reaction. What they want? Equilibrium constant, K equilibrium. They gave E. What is the relation between E and K equilibrium? We know this equation delta G naught equal to minus NF E naught, correct? One more equation we know. Delta G naught equal to minus RT ln K equilibrium. Equate both. What do you got? NF E naught equal to RT ln K equilibrium. Bring this RT to this side. What do you get? NF upon RT 2.303 RT. I am writing 2.3. This ln can be written as into 2.303 into log K equilibrium, right? Bring that to this side. NF upon 2.303 RT response, sir, into E naught is equal to log K equilibrium. So K equilibrium equal to 10 power this value. Respond, sir. Respond. 2.303 RT by NF is 0.0591. Now it is 1 upon 0.501, 0.059. 2.303 RT by NF is 0.0591. It is the reverse of it, na? Reciprocal of it, right? So 10 power, what is E naught? 0.59 divided by 0.0591. Response, sir? Correct? So what you got? You are getting 10 power 10 times. Oh, N means how many electrons? N, sir. N we missed, na? N is not 1, na? Manganese from +7 converted to +2. +7 to +2 means 5. Right? So N factor is 5 means into 5. So K equilibrium equal to 10 power 50. Yes, sir. Online. Clear?
Yes, sir.
So today I will stop the discussion, sir. Right? So next class we will start solid state. Coming week, I am thinking like to take more classes. Right? In next week, I will close solid state chapter. Right? Obviously, I will increase the speed. I already posted the notes, complete notes I have posted, right? So keep that notes with you. At least if possible, go through the notes once because it is purely math, no chemistry in it. Solid state chapter is purely mathematics only, simple geometry, right? Once go through the notes, right? So next week I will close that chapter. Then target one is completely over, right? Right, sir, I will end the session.